This video is about the Kaplan-Meier curve. We'll go through what the Kaplan-Meier curve is and how you can create it. The formulas used are from the very recommendable book Survival Analysis by David G. Kleinbaum and Mitchell Klein. And we get started right away. The Kaplan-Meier curve is used to graphically represent the survival rate or survival function. Here the time is plotted on the x-axis and the survival rate on the y-axis. But what is the survival rate? Let's say you are a dental technician and you want to study the survival time of a filling in a tooth. So your start time is the moment when a person gets a filling at the dentist, and the end time, the event, is the moment when this filling breaks out. You're interested now in the time between these two situations. In the Kaplan-Meier curve, you can see how likely it is that a filling will last longer than a certain time. For example, you might be interested in the probability that your filling will last longer than, let's say, 5 years. In order to do this, simply read off the value at 5 years to see how high the survival rate is. At 5 years, the Kaplan-Meier curve gives you a value of 0.7. It is therefore 70% likely that a filling will last longer than 5 years. Therefore, the survival time curve tells you how likely it is that a person survives a certain point in time. This leads us to the question how you can create a Kaplan-Meier curve based on your own data. Here I will show you how you can easily create the Kaplan-Meier curve online with DataTab, and then we'll go through how you can calculate the required tables by hand and how you can draw the Kaplan-Meier curve using these tables. In order to create the Kaplan-Meier curve with DataTab, simply visit datatab.net and copy your own data into this table. Now you click on plus and select Survival Analysis. If you now select the variable time, DataTab creates the Kaplan-Meier curve, and here below you see the survival table. If you don't click on a status, DataTab assumes that none of the data is censored. If this is not the case, you need to click on the variable that contains the information which case is censored and which is not. 1 stands for event occurred and 0 stands for censored. Now you get the appropriate results for this down here. If you had factors where you wanted to check if they have an influence on the curve, you click on them here and the log rank test or the Cox regression would be calculated for you. But now I will show you how to create this table and the curve yourself. To create a Kaplan-Meier curve, you first need the data of your test patients. Let's say the filling lasted 3 years for the first test person, 4 years for the second, 4 years for the third, and so on and so forth. Of course, the data are purely fictitious now. Let us first assume that none of the cases is censored. The data are already arranged in such a way that the smallest survival time is at the top and the largest at the bottom. Now we create a second table which we can use to draw the Kaplan-Meier curve. For this, we look at which times occur in this table and also add the time 0. So we have 0, then 3, 4, 6, 7, 8, 11 and 13. In total we have 10 participants. Now we look at how many dental fillings break out at which time. We enter this in the column M. So at time 0, 0 fillings have broken out. After 3 years, 1 filling has broken out, and after 4 years, 2 fillings have broken out. Finally, after 6 years, 1 filling has broken out. We now do this for all other time points. Next, we look at the number of cases that have survived to that time plus the cases where the event occurs at the exact time. We enter this in the column n. So now n is the number of cases that survived until that time, plus the people who drop out exactly at that time. After 0 years, we still have all 10 people. After 3 years, we get 10 for n. 9 people still have their filling healthy, and 1 person has their filling broken out exactly after 3 years. The easiest way to get n is to calculate the previous n value minus the previous m value. So we get 10 minus 1, which is equal to 9. Then 9 minus 2, which is equal to 7. 7 minus 1, which is equal to 6, and so on and so forth. From the column n, we can now calculate the survival rates. For this, we simply divide the value n by the total number, in this case 10. Thus, we get 10 by 10, which is equal to 1, 9 by 10, which is equal to 0.9, 7 by 10 is equal to 0.7. We now do the same for all others. Now we can draw the Kaplan-Meier curve. At time 0, we have a value of 1. After 3 years, we have a value of 0.9 or 90%. After 4 years, we get 0.7. After 6 years, 0.6, and so on. Now we can plot these values. At 0, we have 1. At 3, we have 0.9. At 4, we have 0.7. And at 6, we have 0.6. Thus, we can now read from the Kaplan-Meier curve what percentage of the filling has not yet broken out after a certain time. But now we will still have to look at the case when sensor data is available. For this, I simply added sensor data in these 3 places. If you don't know exactly what sensor data is, feel free to watch my introductory video on survival time analysis. We now need to incorporate this data into our table for the Kaplan-Meier curve. So we create our M exactly the same way as before. We look at how many cases failed at each time. Now we add the column Q. In the column Q, we enter how many cases were censored at the respective time. It should be noted that the time at which the respective censored case occurred does not get its own row, but it is assigned to the previous time. Let's take a look at this case. The censoring has taken place at time 9. In this table, however, there is no time point with 9 years, and it is also not added. The respective subject is added at time 8. Now we can again calculate the values for the survival time curve. If sensor data are available, this is a little more complicated. For this, we write down these values in the first step. We get these values by calculating n minus m divided by n. So in this row, for example, we get with 12 minus 2 divided by 12 the value 10 divided by 12. The calculation of the actual value is done iteratively. For this, we multiply the result from the previous row with the calculated value. So in the first row we get 1. Now we calculate 12 divided by 13 times 1, which is equal to 0.923. In the next row we calculate 10 divided by 12 times 0.923 and get a value of 0.769. We take this value again for the next row. We now do this for all rows. Afterwards, we can draw our Kaplan-Meier curve in the same way as before with this data. Now it could be the case that you have 2 different materials for the filling and you want to check if the material has an influence on the survival time of the filling. If you want to know how to do this, please watch my next video on the log rank test. I hope you enjoyed the video and see you next time.